Hello and welcome to the next episode of the Klingberg Wing Mark II development. We're outside today here in the front yard with a center section with the new wheels on it and some other new things that I thought I'd show you and talk you through today. We're getting ready to go out and do more testing. We'd go this weekend, but the winds are going to be bad at El Mirage, so maybe another week and a half or so we'll be out. My lovely daughter Amelia is modeling the new setup of everything, and I'm going to walk you through this. We've been focusing more on doing the test flying off of wheels. We feel that we can get a lot more work done that way than lugging the thing up and down the sand dune. And we've had some issues with wheel placement, but I think we got it straightened out now, and wheels that are strong enough, got that taken care of, I believe. And I think in the future, you know, given that most of the hang glider pilots are getting older and not quite as agile, more people might be looking for wheels and do more towing operations. I think the run off the side of a mountain hang gliding is kind of fading as a sport, and that's kind of shifting to paragliding. I think hang gliding is kind of shifting to ultralight sailplanes that would be towed aloft. So we've made several changes since our last outing when I popped up into the air and then flopped back down and broke the landing gear. I've put on a considerably smaller front wheel to accommodate a different arrangement of the rear wheels. You see now that there are push rods here with regular rod end bearings on them, and they're adjustable so that we can keep the nose wheel centered, and the pedals are smaller and lighter weight, and the mounting plate system is different. You see that it's mounted with just 2 bolts with wing nuts, and what I did is right here I bonded another piece of tubing onto the main cross member here, and that provides a flat surface here, top and bottom, and that keeps the plate for the steering pedals, keeps them from rotating around the tube. So this is bonded in place and stays on the glider. This is removable quite easily. Just undo the 2 wing nuts and slide her aft, and off she comes. The front end here, the pivot tube for the steering, the front wheel, is extra tall here because there's several rings of carbon fiber tubing here that allow me to adjust the static angle of attack on the ground. Each one of these rings represents 1 degree, and we can unscrew and pull this bolt out and take one of these rings out and put it underneath here, and that jacks up the nose. So I have a total of 3 degrees that I can bring the nose up. Right now, before we had the nose set at about 2.2 degrees, thereabouts, give or take, and I now have the static angle of attack on the ground set at 5 degrees, and I think that's about appropriate. We might want to bring it up another degree or 2. I've also put a plate here on the front end and made more of a box out of this fitting for the front compression strut, and I put this plate on here so we can put in this eye bolt, and that is we'll thread the tow rope through here so that we can do a legit Y bridle, so that we're towing through the center of gravity, which was a bit of an issue last time. So this is all set up much better for towing. This stays on the aircraft. Also, I've added tow clips to the steering pedals, and what that allows the pilot to do, and Amelia will demonstrate this for us, you can push yourself fore and aft with your feet, right? Push yourself aft, there you go, she swings aft, and because we have tow clips, it's easy for her to pull herself forward without her feet coming off the pedals, and that is to help damp any extreme oscillations in flight. If she gets into a pecking mode, this swinging will help damp that out, we hope. And in addition, it will allow the pilot to control the speed of the aircraft. This is set up much like a Casper wing, where the pilot is free to swing fore and aft for pitch trim adjustments. So when you want to fly fast, you just pull yourself forward, Amelia, pull yourself forward with your feet, just pull, swing forward, there you go. Be able to pull herself forward like that to go fast, and push back, push all the way back, and that would be the go slow mode. So you can make trim adjustments for different flight speeds without incurring a drag penalty by changing the controls on the wing itself. So it's a low drag way of adjusting speed of flight. and that's for cruising between thermals. If you're going between thermals or you got to go fast somewhere, you pull yourself forward. You want to slow up for in the thermal, you push yourself back. Now, what I have set up temporarily here is a wood board. Here you can see it spans across the width of the pilot's cage, and it has the 1.5-inch diameter axle now attached to it. I'm using the same wheels we had last time. Axle is much stronger, and you'll see it's bungee mounted, and that's to help absorb any hard landings. And if you've seen my other videos, that's the only kind of landing I seem to have right now is hard landings. So this will help absorb some of the impact. I got to add a few more bungee wraps to this to get it up to about 1.5 G is where the bungee cords would start to become activated. You know, if you we don't want them activated at 1 G. We want it sitting there nice and solid. But if you get a bit of a bounce, you know, they'll have some give to them. And you can see they have about 2 inches of travel here. The axle can come up to the cage here, and I've shortened up the harness suspension system up here. I made new shorter straps for here so that the pilot's butt is well above the axle, so they're free to swing and most likely won't get hit in the butt with the axle. If that did happen, there is polycarbonate inside the harness to protect the pilot. And let's see, what else can I point out over here. I made some changes to the control stick system. Here, hold this up a minute. I've made some changes to the setup here so that we have some free-floating links here to accommodate the turnbuckles for adjusting the tension on the cables, and these links are free to move up and down. Let's see if I can get a closer look at that like that. And that's because we changed back the previous setup. We were trying out some differential in the elevons. I did not like it. It did not give me enough down authority. So we've gone back to equal throw on the elevons, and I had to change the control horns a little bit to accommodate that change. These are back to kind of a normal configuration setup. Now overall, I'd have to say that in real life, the glider would not be set up this way. There's going to be, there would be some type of tub that would bolt on underneath the frame, such that that tub had the pedals and the wheels and everything else integrated with it. So when you want to go foot launch, you just don't attach the tub, and if you want to go towing, then you just bolt on the tub and you got your wheels and pedals and everything else, and it's nice and aerodynamic. It'll all be streamlined in except for the little bit of the wheels that have to stick out. For the regular user, there's probably not going to be steering of the nose wheel. I have a steerable nose wheel here because I have no active yaw control at this point. So there's no way for me to actually steer the glider initially on the initial tow run. Once you're up to about 15 miles an hour, the winglets hold the wing nice and steady, but we'd like to have yaw control on tow. So I suspect that I'm going to be installing cables to activate the winglets, and then there would be pedals in here on a permanent basis that allow control of the winglets, and then you probably don't need the nose wheel steering. Be much like the Swift, where you have two fixed wheels and you use the winglets to steer both on the ground and in the air. I wanted to take a moment in the video to show you that I'm getting set up to put the pilot's cage enclosure on, the components for installing it. It's not a permanent setup. It's installed when you're on site and then removed for transportation. There's be a series of these that go on the uprights around here and up on this upright, and this is the same type of foam rubber that goes in a pool noodle, and it's got nice compressive strength on it, yet some give. This will be in a nylon sleeve, a sleeve of fabric that will then Velcro to the uprights. The fabric will come around and Velcro to the other side so that this is locked in place and it can't rotate like this. And then there'll be a strip of Velcro on the outside of that sleeve so that the canopy can come around and Velcro on here. And then there'll be a flat panel of flexible vinyl here on the side. So that vinyl will go on first, then the front canopy goes around to the front windshield and Velcro's over the top of that. And there'll be a similar type setup here at the bottom, where this wraps around the nose, and that provides a standoff for the front windshield and the side. That gives enough room for the control stick to go to the side like this. And these vinyl panels on the side will be flexible so that it will accommodate movement of the control stick. We won't need one of those bubbles sticking out on the side like the Swift. And it'll be nice and light. And so these can be Velcroed on or removed depending on whether you want to fly with the cockpit enclosure or not. So I'm starting to work on that, but I got some sewing to do yet. So thanks for coming today, and I hope you enjoyed the video. And as I always say, fly safe and bye for now.